Hello, college biology. This is Energy Carriers Part 2. In Part 1, we introduced some energy carriers and the basic idea of what the cell uses energy for, and we kind of left off with talking about spontaneous versus non-spontaneous reactions. We're going to pick up on that discussion this time. So, you may remember from your chemistry, you may be exposed to the idea of endothermic and exothermic reactions. An exothermic reaction releases heat to the environment as the reaction progresses, and an endothermic reaction absorbs heat from the environment as the reaction progresses. Well, we have two different terms that we're going to be using. We're going to be using exergonic and endergonic. And exergonic and endergonic are related to exothermic and endothermic, where those exothermic and endothermic terms are referring to heat energy being transferred. Endergonic and exergonic are more generalized, and they are talking about free energy. That means that there are other energy types that are associated with endergonic and exergonic. Exothermic reactions are exergonic. Endothermic reactions are endergonic, but there can be other energy transfers involved as well. Now, what we really want to talk about is spontaneity, spontaneous reactions versus non-spontaneous reactions. The ball rolling down the hill, that'll happen on its own. The ball going up the hill, we need to push it. We have to put energy in for that to happen. Same thing in our cells. Some reactions will occur on their own. Some reactions need to have energy to occur. So let's talk about an exergonic reaction. In an exergonic reaction, the reactants have some amount of energy stored in that molecule. So this is stored chemical energy. Here, this represents our activation energy. Those molecules are vibrating, possibly moving around, and they have to have a collision that's strong enough that once that collision occurs, there's enough energy transfer, then they'll actually perform the reaction. So this is the activation energy. Once that's been met, then the reaction will occur, and look what happens. We are releasing all of this energy, and these products, they have much less energy than the reactants did. So where did all this energy go? That went back out into the environment as probably heat or motion or some such. Maybe light, depending on the reaction. So now we've got all of this goes out to the environment. Now this is a spontaneous reaction. This occurs on its own. Now why is that? Why would this occur on its own? Well, if we go back to our second law of thermodynamics, the entropy of the universe is increasing. That means that it is the natural state of things to release energy to the environment. When a reaction does release energy to the environment, that's going to happen on its own. That's part of our second law. Hey, entropy is being supported. More entropy is being created. That just happens. So because this is an exergonic reaction, it releases energy to the environment, which occurs spontaneously. This reaction doesn't need any help. Let's make a contrast. Endergonic reactions. Here we have our reactants. They have some amount of energy. There is an activation energy that needs to be overcome to make the reaction go forward. But once we're here, you'll note that the products have a lot more energy than the reactants. That means that the universe is going to want to release as much energy as possible. It wants that energy to be released to the universe as heat or motion, which means even if you put a lot of activation energy, we could backslide and go back to the reactants. No. If we want this to go forward, we got to put in a lot of energy so that those products can store all of that energy and be stable at this particular state. We need to put energy into this. We need to push this ball up the hill. This is not going to happen on its own. So, that is our issue. That is our problem. Endergonic reactions need energy to go forward. Exergonic reactions release energy and happen spontaneously. ATP solves the problem of linking endergonic and exergonic reactions together. I'm going to discuss more about how ATP coordinates these reactions in our next video. I hope this helps. Struggle well.